Previously, we discussed line protection history for various voltage levels and how systems adapt as voltage increases. Higher voltage means greater importance and potential losses. For medium voltage, one relay suffices, but high voltage may require two independent relays with distinct methods. Each operates independently. This episode covers communication systems for line differential protection and information transmission between line ends. As voltage increases, its importance grows. For medium voltage, one relay suffices, but high voltage may need two relays. Each relay must function independently. In this episode, we'll explain line differential protection communication systems. To protect the transmission line, a CT with a differential relay is placed at both ends. Each relay calculates currents to decide on issuing a trip signal. Each relay must operate independently, meaning they work simultaneously without complementing each other. We'll explain line differential protection communication systems and how information is transmitted between transmission line ends. To protect the line, we place a CT with a differential relay at both ends. Each relay calculates differential and restrained currents separately to decide on issuing a trip signal. To calculate these currents, I need the input and output currents of the protected element, i.e. the local current at my station and the remote current at the other station. This allows for current comparison, so we need a method to achieve this. To protect the transmission line, CTs with differential relays are used at both ends. Each relay calculates differential and restrained currents to decide on a trip signal. I need the input and output currents of the protected element, meaning the local current at my station and the remote current at the other station. We aim to get the closest value to the true remote current. The main challenge is time synchronization, ensuring signals reach both ends simultaneously. A delay in the remote current's arrival can cause the relay to see only the local current, increasing the differential current. To calculate the differential and restrained currents, I need the input and output currents of the protected element. Knowing the local current at my station and the remote current at the other station on the transmission line is essential. We need the true remote current. The main challenge is time synchronization. When the signal reaches both ends, if the remote current value is delayed to the local relay, it will see the local current without the remote one, increasing the differential current and causing a false trip decision, mistakenly indicating a fault. The diagram shows that if an external fault occurs, the error in current difference due to signal delay increases with delay time. We can obtain the closest value to the true value of the remote current, and the biggest challenge at this stage is what is called time synchronization, meaning when the signal will reach both ends. If there is a delay in the arrival of the remote current value to the local relay, this relay will see the local current at a moment when it does not see the remote current. At that moment, the value of the differential current will increase. A false trip decision may occur. The diagram shows that an external fault increases error value between currents as delay grows. Researchers seek fast, accurate data exchange over distances. Key question: what info is needed for transmission and how will it occur? Crucial data includes current value from the other end. If a fault is detected, a trip signal is sent to the local circuit breaker and an inter-trip signal is sent to the other end. The researcher began looking for ways to ensure the transmission and exchange of information and data between different stations over these large distances with high speed and accuracy. Here, we ask the following question: what information do we need to transmit from one end to the other, and how will the transmission process take place? The most important information we need at this stage is the current value from the other end. Additionally, when the relay detects a fault at any of the ends, it will issue a trip signal to its local circuit breaker. To facilitate the trip process, it will send an inter-trip signal to the other end. It is known that if a fault occurs, we disconnect every circuit breaker that has even a 1% chance of feeding the fault. So, if a fault occurs on the transmission line, we must disconnect the circuit breaker at the beginning of the line and the circuit breaker at the end of it. If we only disconnect one circuit breaker, there is a chance that the fault could still be fed from the remote circuit breaker. In summary, we need to transmit the current value as an analog signal and the trip signal as a digital signal. We distinguish between pilot scheme and pilot protection. Transmitting trip signal information as logic, zeros and ones, is a pilot or communication scheme. This scheme is unrelated to current transmission, and the signal is a carrier or teleprotection command. TUS scheme and pilot protection. So, if the information related to the trip signal is transmitted to the other end in the form of logic information, like zeros and ones, this method called a pilot scheme or communication scheme. The communication scheme is not related to the transmission of current, and the signal transmitted through the communication scheme is referred to as a carrier signal or teleprotection commands. Carrier signal, teleprotection compass. This signal doesn't disconnect the other end. It uses logic from the trip method. Communication schemes speed up the trip process. Direct tripping, permissive tripping, and blocking are common. They either trip the circuit breaker or prevent it. Each has pros and cons in speed and reliability. The image shows the fastest and most reliable scheme in green, the blocking scheme, while the safest against accidental internet trip commands during communication issues is the direct internet trip, shown in red. Among these schemes, which are commonly used in distance protection, are the direct tripping scheme, the permissive tripping scheme, and the blocking scheme. The essence of these schemes is either to request the disconnection of the circuit breaker, as in the transfer tripping scheme, which includes the direct tripping scheme and the permissive tripping scheme, or to request to prevent the disconnection of the circuit breaker, as in the blocking scheme. Each scheme has its own pros and cons regarding speed and reliability. The fastest and most reliable is the green blocking scheme. The safest against accidental internet trip commands during communication issues is the red direct internet trip. However, the blocking scheme is the least secure, and the direct internet trip is the least reliable due to communication faults. This image from Network Protection and Automation Guide, Chapter 8, shows a difference in security. The direct intertrip scheme isn't the best in practice, leading to the accelerated zone concept, often Zone 2 protection, in both blocking and permissive schemes, used to confirm faults before tripping. At the same time, we note that the blocking scheme is the least secure of them, and we also note that the direct internet rep is the least reliable or dependable of them, because in the event of a malfunction or failure in the connection, there will be no chance of disconnecting using it. Although this image is taken from the book Network Protection and Automation Guide in Chapter 8, there is a difference regarding the security factor. The direct intertrip scheme isn't ideal, so the accelerated zone, often Zone 2 protection, was introduced in both blocking and permissive schemes. It confirms faults before tripping. If a remote circuit breaker trips via a carrier signal or communication schemes, it's due to the intertripping signal. The local relay's decision is the tripping signal, while the remote's is the intertripping signal. Protection engineers must distinguish between trips from local or remote relays. If a remote circuit breaker is tripped via a carrier signal or communication schemes, it's due to the intertripping signal. The local relay's trip decision is the tripping signal, while the remote relay's decision is the intertripping signal. As a protection engineer, distinguishing whether a trip is from the local or remote relay is crucial. Typically, this distinction is made using a latching LED or a relay with a flag for the remote relay's trip decision, denoted as carrier or pilot wire receiver relay, ANSI device code 85, unlike the lockout relay, symbol 86. Distinguishing between the cause of the trip coming from the local relay or the remote relay is the first step in fault investigation. It raises the question of why I spent my time investigating the cause of a false trip when the trip signal didn't even originate from my end. They are distinguished by a latching LED or relay from the remote relay, called the carrier or pilot wire receiver relay, symbol 85. This differs from the lockout relay, symbol 86. The 85 relay is self-resetting, with a non-latching contact that opens automatically. Lockout relay is hand reset, stays closed. 85 relay resets itself, 86 lockout needs manual reset. 85's contact opens. The 85 relay is a self-reset relay, meaning its contact closes and opens automatically after a red command. In contrast, the lockout relay is hand reset. Its contact stays closed until manually reset. According to ANSI device code, 85 is a receiver relay, 86 is a lockout relay, and 87 is a differential relay. Details of communication schemes will be covered in the distance protection course. Pilot schemes differ from pilot protection, which involves exchanging current values on both sides, represented by the differential relay, until someone comes and presses the reset push button for this relay. So according to the ANSI device code, the symbol for the 85 relay is a receiver relay. The 86 is a lockout relay, and the 87 is a differential relay. As for explaining the details of all the communication schemes and how they work, we will delve into that more in the distance protection course, God willing, if there is still time left. What was explained earlier is what is called pilot schemes or communication schemes. On the other hand, pilot protection, or what is known as carrier current protection, is completely different. In pilot protection, the current values are exchanged on both sides, which is represented by the differential relay. The local current is the actual measured current, representing the true current. While the remote current is a virtual value that comes through or via communication and appears in the form of pulses, due to the importance of transmitting and exchanging information between stations, a communication system was established within each station. This system aims to facilitate communication between the units of the station itself through a local area network, which is a small geographical area known as the LAN network, Communication can also be established between the station itself and other stations over a wide geographical area. The concept of a network, in its abstract form, consists of two words: resource sharing, meaning the exchange or sharing of resources, regardless of the method used. Any two entities that exchange information or resources are considered a network. Examples of networks around us include Bluetooth and Wi-Fi, and even social media platforms are called networks because they involve people exchanging information with each other. Scientists classify networks based on their size, cost, and specific configurations into several types. We start with the first type, which is the PAN. This is an abbreviation for Personal Area Network, which refers to personal networks that connect only two devices. They are usually called peer-to-peer, like when you send a print command from a laptop to a printer or transfer a photo using Bluetooth or other data transfer technologies between just two devices. A PAN network usually covers a small area or a distance of about 1 to 10 meters. Some say that the term network is only used when connecting 3 or more devices together, and it is not referred to as a network when only 2 devices are connected. So, if more than 2 devices are connected together, we call this network a LAN, or local area network, which is found in laboratories, homes, offices, and other places, covering a distance from 10 meters up to 1 kilometer. If you want to connect 2 cities together, which is usually done by governments to link networks or CCTV cameras, we use a network called MAM, which covers a distance from 10 kilometers to 100 kilometers. If you want to connect or link countries together in a wide geographical area, we use a network called a Wide Area Network, WAN. There are many other classifications of networks as shown in this image, but there's no room to mention them all here. You can refer to them for more details. An inspiring national renaissance. The steps for transmitting information between stations involve sending a signal to the transmitter or sender located at the same station, which then sends this signal to the receiver located on the other side. This receiver, in turn, connects the incoming information from the other side to send it to the relay located at the same station. As for the media for signal transmission between both stations, it can be done using one of these 4 methods, either through power line carrier, which is abbreviated as PLC, or it may be referred to as PLC communication, or through radio channels, or it may be called microwave channels, or between both stations, can be done using one of these 4 methods, either through power line carrier, which is abbreviated as PLC, or it may be referred to as PLC communication, or through radio channels, or it may be called microwave channels, which is the 4th method. The last method is through fiber optic cables, and we should consider the topic of the transmission. Through radio, fiber optic cables, consider interference from lightning when choosing methods. Transmit signals over power lines without special wires. Or arising from the operations of, or arising from lightning strikes should be considered when choosing each method among them for the communication system using. This method transmits communication signals over the power line itself, where the way of transmitting information between stations is characterized by the absence of wires and special communication extensions. As the transmission occurs through high voltage lines, they are originally extended for power transmission for this reason. It is called PLC communication. Uses the same power line to transmit signals, carrying 200 megawatts of power. It also transmits information up to 10 watts. Information is sent and received at different frequencies to prevent interference. PLC is ideal for long lines. A PLC device is needed at both the station and control center. Initially, PLC networks supported direct telephone links. With RTUs for SCADA, analog systems were replaced by digital modems, creating multiple channels with data rates up to 64 kilobits per second or higher. They operate at a different frequency, far from the base frequency, to avoid any interference, as no one can listen to multiple people talking at the same time and understand everything they say. The PLC method is the most suitable for long transmission lines that can extend for several hundred kilometers. It is essential to have a PLC device inside the station and another at the control center or at the other station. PLC networks originally supported direct telephone communication, which is the link and telephone between the substations and control centers. However, after using RTUs in the substations for SCADA applications, analog systems were removed and digital modems were used instead. These digital modems are capable of creating multiple transmission channels with data rates reaching up to 64 kilobits per second or even higher. allowing for the reception of various information. The signals coming from the digital signal unit through the modem. Typically, a modem is used when there is a difference in the nature of the signal on both sides, so the modem connects them. To establish this connection, it is essential to perform a process, and this is where the name comes from. Modem converts the digital signal to an audio frequency, but at a frequency ranging from 2 kilohertz to 4 kilohertz, known as audio frequency. The modem sends a signal to the environment, converting it to a medium frequency, known as the internet, through a device card. The wave frequency is then modulated to high frequency and sent over the line. This conversion prevents data loss during modulation stages, avoiding natural distortion. These frequencies, ranging from 4 to 11 megahertz, are higher than those in fault signals. Finally, the signal is amplified by a power amplifier to be sent over high voltage lines of 400 or 132 kilovolts. And then finally to the stage, so that there is no natural distortion in the wave during the modulation from one stage. This way, we don't lose any data or information. These frequencies are, of course, higher than the high frequencies that might be present in the signal during faults, and they usually range from 4 to 11 megahertz. This range does not exist in fault signals. In the final part of this process, the signal is amplified and given a certain amount of power by a power amplifier so that we can send it over high voltage lines of 400 kilovolts or 132 kilovolts. Once the waves transmitted over the high voltage lines reach the other station or the control center, what is called in order for the excess waves to be captured by the Wi-Fi trap, the term trap here means a filter or a snare for specific waves and not others, as if we are creating a filter that allows the excess waves to capture communication waves from the power lines and then pass them to the control center where they are received by the PLC device. This PLC performs the reverse operation by converting or modulating the wave frequency from high frequency to intermediate frequency. And then it sends it to the cities. The modem converts the signal and then sends it to what? The device that processes it and then sends it to the computers. What is the creative function of the Wi-Fi trap, also known as the line trap, and how does it capture communication waves while ignoring others? In other words, how does it distinguish the communication signal from the power signal? The line trap is connected in series with the connectors. Entering the station links to 1 or 2 fuses requiring high voltage. It includes an inductor with thick wires for up to 2,000 amperes. These allow 50-60 Hz block high frequencies. Another circuit is 0 at 50-60 Hz high against high frequencies, directing them to enter first. It is an inductor made from very thick wires capable of withstanding current values passing through it, where the rating can reach up to 2,000 amperes. Meanwhile, the inductance value ranges from 0.1 to 2 henries. These circuits allow currents at a frequency of 50 Hz or 60 Hz, depending on the network frequency, while blocking high frequencies. Another capacitor connected to the receiver is adjusted for these circuits, which are originally designed to have a value equal to 0 at 50 Hz or 60 Hz frequencies. The same capacitor has a high value against high frequencies. The goal of making this value high is to force the high frequencies, which are specific to the communication system, to enter before. Its capacitance is very small. Its function is to ensure the passage of high-frequency currents while preventing the entry of currents with a frequency of 50 Hz or 60 Hz. For example, if the capacitance value is 2 microfarads, if the network frequency is 60 Hz, then the value of the capacitor will equal 33 kilo ohms at 60 Hz. Meanwhile, it will only be 40 ohms against frequencies of 200 kilohertz. We want to point out here that the use of CVT in stations has increased for 2 reasons. The first reason is that it is less expensive than magnetic voltage transformers. Additionally, the cabling inside it can be used in the SCADA system. Communication signals enter through the CVT to the receiver. It performs the matching or connection between both sides, the PLC side and the power side, where each side contains a coil with its own specifications, in addition to providing isolation from the power frequency or the transients coming from the line. Let's assume that the For this line toner, we'll have a value of 40 ohm, which means that the equivalent reacts to the components connected in series will be 0, which means that the signals transmitted at high frequencies, which are the communication signals, will enter and exit through this path without any significant resistance or opposition. This drain coil is used to prevent the signal from going to the ground by creating high resistance against high frequencies. At the same time, it allows the signal to discharge to the ground, meaning it represents, by discharging the signal to the ground, it essentially means it represents in front of the, and one of the most famous devices in the market is the ABB device and the Siemens device. Through practical experience at the sites, it was found that the first type is more stable, reliable, and can withstand high temperatures compared to the Siemens devices designed for the same operating conditions. However, the devices are considered more challenging to work with. The second method for transmitting signals between stations is by using the first method is using the CVT, and the second method is using throughout the long duration of the long duration, it is the only means of communication that was available and used in traditional differential protection, which has started to be abandoned in favor of chaos. In recent years, referred to in Arabic as the guiding cable, and the gold symbol is PW. Differential protection, which was represented by the symbol. The PW power wire is a special metallic cable designed solely for signal transmission. It is well shielded to prevent interference from surrounding vibrations and voltages through the power circuit, which can accidentally create induced voltage. These induced voltages or inductive voltages increase with, of course, these special cables are laid underground along with the high voltage lines. Between the stations, this cable is suitable for lengths of up to 25 km approximately. If the distances are short, there are no special requirements or measures needed. They think about interference or disruption in the signals, while in long distances, we might need devices to amplify, send, and receive these signals. We can use our own equipment, meaning we can extend it ourselves, or we can also rent channels from telecommunications companies, especially if the owner wants to save some money spent on maintaining and installing these cables. This can be done by renting the pilot wires. These cables are isolated from power lines. Renting pilot wires has issues. Telecom companies may reroute cables without notice, causing problems. Excitation transmission time is crucial. They may limit capacity, speed, and distance with fines for exceeding. Using your own, you remain free, uncontrolled for end data transmission. Because the excitation transmission time is very important and sensitive for them, in addition to the fact that these companies may allow you to transmit a specific capacity at a specific speed and distance, exceeding these limits could result in some fines. However, if you use your own equipment, you will remain free and no one can control you. The issue of data transmission is a matter of ratio and requires an economic and technical study from specialized experts. Throw the data. It's a matter of ratio and requires an economic and technical study from specialized experts. In the same way as before, cities are usually used to receive the digital signal coming from the RTU, then it converts it to the original signal and sends it through the pilot cable. We then transfer this pilot cable to the control center or to another station where it is received by another modem. This modem at the other station then converts the signal to digital and then to the tab control information. And they are the inspiration for a national renaissance. The third method for transmitting signals between stations is by using radio channels. So the first method is using, and the second method is using. The third method for transmitting signals is by using radio channels. This method relies on sending signals remotely through electromagnetic waves. This is what is indeed called wireless communication. This method is characterized by having its path completely independent from its own. Therefore, it is not affected by voltage, or the word radio comes from the Latin word radius, which means radius. It was named this way because electromagnetic waves are transmitted through the atmosphere in the form of circles. These electromagnetic waves come in many types and vary according to their frequency and wavelength. Among them are the radio waves known in radios, ultraviolet waves, infrared waves, and microwave radiation, in addition to visible light and rays. The channels used between the stations are what we call microwave channels, which typically operate at a signal frequency ranging from 3,000 to 12,000 megahertz. Communication between the dishes on both sides must be established on a line of sight basis. This means that each dish must be able to see the other within its horizontal line of sight. This is why communication towers are always elevated or placed on tall buildings. It is preferable to consider that wind or temperature changes should be at their lowest levels at this height. If there are obstacles between the communication towers, or if there are many bends in the path, we will have to use a repeater station along with all its components to strengthen the signal and resend it again. The bun is what makes reliance on it much less than the environment, where the connection is direct between one end of the line and the other. One of its downsides is that atmospheric pollution can cause deviation or refraction of the wave, which may reduce the efficiency of the transmitted wave. It is common to use digital radio systems that utilize pulse code modulation, and here we will pose a new question. Why do we always need? What is the duration for? To transmit the communication wave? Let's assume you want to send a paper message to a house that is 100 meters away from you. If you just throw the paper as it is, will the message reach the house? Of course not, because the paper itself is weak. But if you put a stone inside that paper and then throw it, it will reach a farther distance because of the weight of the stone inside it, right? So we can conclude that the stone is what carried the message to a farther distance. Here, the empty, weak paper can be likened to a low-frequency signal. In the world of communication, you can't send a weak signal over long distances without experiencing losses or loss of the information itself. Therefore, we rely on another strong signal with a high frequency, which we compared here to the stone, to carry the original signal. To farther distances, which is called modulation, and embedding or introducing a strong signal into a weak signal makes the weak signal strong. This is what we refer to as modulation. Additionally, the height of the transmission tower is directly proportional to the wavelength of the signal, where it equals 4. The wavelength value increases as the frequency value decreases, and vice versa. If the frequency is 15 kilohertz, then the wavelength of the signal is the speed of light divided by the frequency, which means 10 to the power of 8 divided by 15 kilohertz, and it equals 20 kilometers in this case. The height of the transmission tower would be 20 kilometers divided by 4. It equals 5 kilometers, which is impractical. The frequency is 1 megahertz, the wavelength is 300 meters, and the tower height is 75 meters. Speed equals distance over time, where speed is light speed, distance is wavelength, and time is frequency. The period of one cycle is t, 1 over f. Speed equals wavelength over t, and 1 over t is f. Speed equals f times wavelength, meaning wavelength equals c. Light speed divided by f. Sending a signal without modulation is weak and suffers significant losses. Speed is distance over time, specifically light speed. Sending a signal without modulation is problematic due to weak signals and losses. Low-frequency waves need tall towers, impractical to build. High-frequency waves have less interference. Speed equals frequency times wavelength. Wavelength equals speed of light divided by frequency. Direct signal transmission is weak and loses energy. Low frequency needs tall towers, impractical. High frequency interference is less. 2 MHz and 6 MHz waves differ by 4 MHz, reducing interference. Wave characteristics, phase, frequency, amplitude, strengthened by adding carrier signal to message signal, called modulation. Low-frequency waves require very tall towers, which is practically impossible to implement. Additionally, the likelihood or percentage of interference from high-frequency waves becomes less. For example, if I have a wave with a frequency of 2 MHz and another wave with a frequency of 6 MHz, the difference between them will be 4 MHz, which is a significant difference.
This means that the interference or mutual interference between the two waves will be very minimal, since a wave is described by three characteristics: phase, frequency, and amplitude. We strengthen it not by modifying the original wave, which is called the message signal or baseband signal, but by adding a strong carrier signal to it. This process is known as modulation. When the transmitted signal reaches the other end or the receiver, this device performs demodulation, meaning it separates the original signal, which is the message signal, from the carrier signal. Thus, the frequency of the message signal can be increased by adding a high-frequency carrier signal, which raises the frequency of the message signal. Modulation changes the signal's amplitude, AM, frequency, FM, or phase, PM. AM is continuous wave modulation, FM, and so you hear this as FM frequency modulation, or if you change the phase value, you hear it as PM phase modulation. Amplitude modulation falls under continuous wave modulation, while frequency modulation and phase modulation fall under analog modulation, which is also part of continuous wave modulation. These terms are the same ones used in radio channels, where broadcasting used to come in the form of AM amplitude modulation, typically ranging from 500 to 1100 kilohertz, or a range from 500 to 1600 kilohertz. It later evolved, and broadcasting started to come in the form of shortwave and FM frequency modulation waves in the range of 58 to 108 megahertz. Of course, modulation is a world of its own. There's analog modulation, which is specific to analog communication, and there's also digital modulation, which is specific to digital communication, and this has developed in the realm of modern computers. Recently, there has been a reliance on digital communication for communication or transferring information between stations due to its ability to transmit large amounts of data using multiplexing. Currently, point-to-point communication, which was used in traditional security systems, is being phased out, and transmission channels are being implemented in the digital communication network. Inspiring. Revival of a nation. The types of modulation can either be continuous wave modulation or pulse modulation. Continuous wave modulation, which means the continuous wave, includes AM, FM, and PM, which we have explained. As for pulse modulation, it falls under either digital modulation or analog modulation. Analog modulation has three methods. The first is amplitude modulation, the second is width modulation, and the third is position modulation. Worth modulation indeed. And the third is As for digital modulation, we have several methods under it. Amplitude shift keying, symbolized by ASCII, phase shift keying, symbolized by BSK, frequency shift keying, symbolized by FSK, in addition to pulse code modulation. Pulse code modulation, symbolized by BCM, is currently used in stations and is approved by the Communications Authority for economic reasons, of course. You can visit this channel for more details if you want to learn more about the topic of modulation. Now, we want to ask the following question. Can anyone tune their device to the same frequencies to receive these signals? Or in other words, can anyone hack these frequencies? For example, I could intercept wireless signals between stations by having prior knowledge of these frequencies and then send disconnect signals to cut off all the stations in the national network to avoid this very serious problem. Usually this is done through encrypted and complex messages, which are sent to ensure that, and so on, the required security is achieved, and the necessary disconnection speed is accomplished at the same time. If an unknown person connects to these frequencies and receives these messages, they will not be able to decode them. Usually, the sender and receiver agree on a method to change the frequency in a way that prevents interference and eavesdropping as well. The role of firewall and cybersecurity comes to protect programs, systems, and networks from any digital attacks. According to a study conducted by some Arab engineers abroad studying the blackout cases that occurred on electrical networks all over the world, this route attached and published in their research, where on November 23, 2015, a cyber attack occurred on the electrical network in Ukraine, and a large part of it was exposed in a blackout case. For those who want more information about this research, they can refer to this link, which is available to everyone and is open source. In fact, most of what has been explained in this episode is closely related to telecommunications or network engineering beyond the scope of electrical power engineers. I summarize this information so we can gain a comprehensive understanding of communication systems between electrical stations. Stay tuned for the next episode, where we will explain the fourth method of communication links between the two stations, which is using fiber optics.